So this section is chapter 11 plus, and it is not in your book. So make sure that you go to Canvas, go to assignments, and click on the attachment that I put in there for chapter 11 plus, and you'll see the reading and everything there. We're going to do example 3. So if I go to the book, here's the handout that I gave you. It actually starts at interpret data, linear and quadratic, but we're going to jump to example 3 here because I think this is a good example. It says the table below represents the retail sales in millions of sports utility vehicles for the selected years of 1996 to 2012. Notice I kind of wrote on mine, I'm changing 1996 to 6 because it says right here, this is what you got to be really careful in the homework, is let x equal the number of years since 1990. So 1990 is when we're starting to collect the data. And so 1996 would represent a 6 because in 1990 we would say x is equal to 0. So we're not going to type in 1996. We're going to put in 6, which means 1996. 1998 will be 8, 2000 will be 10, 2002 is 12, and all the way down to 2012 is 12. And then I'm going to put in the SUV sales. I don't put in the millions, I just put in the number because the number represents millions because that's what they were selling. So if I go to my board, you can see that I've already wrote down the data that I needed. And so again, we're saying that x will equal 0 at 1990. So this is 6, this is 8, this is 10, this is 12, this is 14, 16, 20, and 22. These are the numbers I put in for the L1. And these I just type in. So that's what I did already on my calculator. So here is my data. If you go to Stat and then go to Edit, which is 1, you see I put all the data in there already. And so you have to put in the data like we did before, back when we did linear regression. And I'm just doing this as a review. But let's say you want to graph this. So if you hit Graph, you got to make sure that you have your window set up. So I have my window set up because 0 to 24 is the smallest to the largest, right? So smallest would be at 0, and then the largest would be at 22. So I just made it a 24 and I counted by 2's. The same thing goes for the y values. I went from 0 all the way up to 6 because it was 4. I mean, you could do 5 if you wanted to. It's up to you. But that way we can see all the data. Now if you don't see any data at all, it's probably because you don't have your stat plot on. So go to second y equals, which is the stat plot, and make sure this is on. Okay, so that has to be on in order for you to see the data. So if we're going to do this as a linear regression, and then we'll do quadratic in the next video, but if we're going to do linear regression, then we would do what? We would have to go to the Stat button. We would move over to Calc. So I move it over to the Calc. I'm doing line regression, which is 4. Okay, and then I just enter into here. Yep. And then I go to vars. Then I go to yvars. I go to function. And then I want it to store the equation in y1. So I hit y1. Hit enter twice, and then it calculates it. So here's my slope at 0.1038, and my y-intercept is 2.31. So in the book, it says, does it say how to round if it does that? So use the graph to visually identify, find the corresponding regression equation. It doesn't say that, but in the homework or on the quiz and stuff, they do say round to maybe the nearest, let's say it's the nearest 10th. This is the 10th this is the hundreds, this is the thousands. Say we're rounding to the nearest thousands. So then that would be, A would be 0.104. So A would be 0.014. And then my y-intercept would be 2.311. So 2.311. So B is 2.311. Is that what I said? Yep. So 2.311. So here's my equation. So this is what I'd have to type into the homework. I'd have to say y is equal to 0.014x plus 2.311. And if I want to graph it, since I've got it already in there, I just have to hit graph and it will graph it. And so that's its line of best fit for a linear. Notice I've got 1, 2, 3, 4, and I got 1, 2, 3, 4. So I got 4 above and 4 below. And if I I forgot to write the equation down, just go to y equals, and here it is again. You just have to scroll through it to get all of the equation. Oops. To get all of the equation. So here's the x, and now here comes the y-intercept. Okay. So if we wanted to do a prediction, let's say now that we have our equation, our prediction is going to be, if I look at the paper that I have here, this one here, does it ask for anything? Yeah, it says if the sales trend continue, predict the number of SUVs that would expect to sell in the year 2018. So we go back to the board, and now I'm going to do 2018. So here is 2018. This was 22, so the difference between these two is 6, so this has to be 28. So to do this one on the calculator is we go to second quit, we have a clear screen, right, and then we'll put in we're going to put in the 28 there. So we go to what? We go to vars, we go to y-vars, we go to function, and then we go to y1. So here's my y1, my equation that I stored it in. I do parentheses and I type in 28, and then I hit enter, and it gives me my value. So about 5.22 is what I get. So 5.22. So at and let's just say, yeah, so at the year 2028, we have sales of 5.22 million sales of SUVs. This is a prediction for linear. And we can see that in the graph that it's going up, but notice the data is actually coming back down. So line of best fit's not the best one. Linear regression is not the best one. So the next video we're going to do is the quadratic, because I think it'll give us a better answer because it'll fit the data better.